right, today we're talking about properties of parallelograms. So let's start off with the basics. First, we use this symbol right here as the symbol to represent a parallelogram. So if you're writing a sentence or describing it, or ever see it, you can use that. Like we could say, the opposite angles of a parallelogram are ... Now, the definition of a parallelogram is a four-sided polygon or a quadrilateral with two pairs of opposite parallel sides. Okay? So, in a picture, what that would look like is any four-sided figure where this pair of opposite sides is parallel as well as the other pair. Okay? So let's see what we can prove about this. We're going to get a couple properties. The definition is going to be really useful because we can use those parallel lines and our knowledge of triangles and parallel lines and transversals to figure some stuff out. Okay, so let's see what we can prove. Well, first, just looking at this shape right here, given these two angles, I know that if I'm walking down a line, I make 1, 2 turns, and I'm going along a parallel line, I know I've made a 180-degree turn in total. So I know that any two, and this is true of any two angles next to each other, right? If I was going up this side and make a turn and then make another turn, again, a 180-degree turn. Since each pair of opposite sides are parallel, then we know consecutive, meaning one after the other, consecutive angles are supplementary or add up to 180 degrees, okay? So that's going to be one useful trick, okay? Now let's see what else we can prove. Okay, going down here, all I did was take a parallelogram and cut it across from one diagonal to its opposite diagonal. Now you could have done this the other direction here too, that's okay, but let's see what we can figure out. Well, I remember from parallel lines that one of the most common tricks is that we have alternate interior angles congruent. So let's look. Because the top and bottom lines are parallel, we know this angle in the top right is alternate interior with this angle. And because the left and right sides are parallel, we also know this angle here is alternate interior with this angle here. So that gives us two angles, and both of these triangles formed share this diagonal. So by ASA, we know the two triangles are congruent. Okay, so let's see what we can gather from that. If I just go ahead and actually, let's do like in blue here, I'll just label this like angle 1, angle 2, angle 3. This is angle 1, angle 2, angle 3. Then what we know is by CPCTC, if we have two congruent triangles, then every part of those two congruent triangles must be congruent. So we'd say by CPCTC, this angle 3 is equal or congruent to this angle 3. And the sum of angle 1 and angle 2 over here is the same as the sum of angle 1 and angle 2 over here. So it looks like in any parallelogram, we just proved that the opposite angles are congruent. Okay, that's going to be useful. Also, since every single part is congruent, we know they share that side on the inside, but also the side between angle 1 and angle 3 up here is congruent to the side between angle 1 and angle 3 in the other triangle. And the side between angle 2 and 3 is the same as the side between angle 2 and 3. So also we know that opposite sides are congruent. We got that just from connecting the two diagonals and noticing that the two triangles formed had to be congruent. Okay, so let's use one last diagonal here and see that if we cut it both ways across the middle, we could see that again, using alternate interior angles, we could get that this one and this one are congruent, this one and this one are congruent. We know that. And we could also say from above, right? What we just proved is that in any parallelogram, opposite sides are congruent. So opposite sides of a parallelogram are congruent. So now we know that this side up here and this side down here are congruent. So by ASA, the two triangles are congruent. Okay, so we got these two triangles are congruent. So again, let's see what that tells us. That tells us if I label these sides again, this is here angle 1, angle 2, angle 3, angle 1, angle 2, angle 3. Let's go ahead and just see by CPCTC, again, just saying, if the two triangles are exactly the same in every way, then every single side must match, every single angle must match. So the side here between angle 1 and 3 must match this side between angle 1 and 3. The side between angles 2 and 3 must match the side between angles 2 and 3. Okay, so by CPCTC, we see that this diagonal this way is cut in half, and this diagonal is cut in half. So we could say that briefly as the two diagonals, and cut in half, we use the word bisect, so the two diagonals bisect each other. Now notice the two diagonals might be of totally different lengths, right? This one here seems to be a lot shorter, and especially if we exaggerate that, we could have a parallelogram like this, where one diagonal is super short and one is much, much, much longer. So notice this is not saying the two diagonals are congruent to one another. It's just saying that this one gets cut in half and the other one gets cut in half. Okay, so let's go down here and summarize that. So in summaries, this is true about every parallelogram. We just drew any parallelogram and proved these three things. So the first one is the opposite sides of the parallelogram are always congruent. Okay? We also know that the opposite angles must be congruent. We know that the consecutive angles, so any two, it's kind of like adjacent, but adjacent has a very strict meaning in geometry. So this means x and either angle, whether we're talking about the angle on, let's use green here, the angle on this side, so x and y here, these would add up to 180. Again, it's simply because we make that 180-degree turn from one parallel line to the other. So consecutive angles are supplementary or add up to 180 degrees. And finally, we have that the two diagonals bisect each other. Okay, so let's actually apply this to a few problems, okay? Down here, this is number 7 from the homework in the book. Solve for D and Z in this image if the shape is a parallelogram. So the key is that we know the shape is a parallelogram. So we can use our properties from above. So looking at this, I know that the opposite sides of a parallelogram are congruent. Again, this is hinging on the fact that it is a parallelogram. So, then I could say the opposite sides must be congruent. So I could say 20 equals z minus 8. So we add 8 to both sides, and we get z equals 28. Great, okay. Now what else could we do? I'll do it in a different color here. We also know, and I'm just looking at these angles here, I know that the opposite angles of a parallelogram are congruent. Okay, so I know that 105 must be equal to d minus 21. So adding 21, we get d is equal to 126. Okay, so that was a really straightforward application of two of the properties. Let's do one more here. This is another one from the homework. So given that this is a parallelogram, that's important, find the measures of all the angles. Okay. So first off, I know that, I know that consecutive angles are supplementary. So that means I know that W plus X is 180. I know X plus Y is 180. So I'm going to go ahead and say the measure of angle W plus 119 degrees is 180. Just saying that I made a 180 degree turn here. So, again, that's because these are parallel. Okay, so let's solve. We go minus 119. We get that the measure of angle W is 61 degrees. Okay. And what else do I know here? Maybe let's do dark green this time. I also know that the opposite angles are congruent. So that tells me that this must be 119 degrees and this must be 61 degrees. So those were a couple quick practice problems. What I'm going to do right now is just go on to IXL and do some more practice. If you're feeling confident, go off and practice on your own. But if you want a little more practice, just stick with me. Okay, so I pulled up IXL. We're starting on N3 up there, so properties of parallelograms. So right away, find the area or find the value of B. Well, I know that these two consecutive angles must make a 180 degree U-turn. So I would say B plus 40 must total 180 degrees. So some algebra, 2B plus 40 equals 180. So subtracting 40, we get 2B is 140. Dividing by 2, we get B is 70. So down here it's submit. Oh, we got to put it in here. We get 70. Okay. Okay, so I remember that my opposite sides are congruent, so I know that this and this will be equal. So 2A equals A plus 37. Subtracting A from both sides, we get A equals 37. Oh, that was a nice one. Okay, so 37. And then, okay, so again, opposite sides congruent. So we get 2Z equals Z plus 2 minus Z. We get Z equals 2. Okay. Oh, so now we got three sides, so we got to choose what relationship we have here. Again, we know that opposite sides are congruent. We don't know anything about this side, so the P minus 1 is not going to help us in this. However, we do know that the side with 4P minus 87 must be equal to the side with 2P minus 17. So subtracting 2P from both sides and adding 87, we get that 2P equals 70, dividing by P. And again, it's asking for the value of P. I'm just double checking because it could at any point ask for what's the length of the side. So we get P is 35. Okay, so let's read this. We've got, if PR, so this one right here, is equal to this expression, and PT is equal to this other expression, then find the value of C. Notice that it's actually saying this is a rectangle. We will discuss later in more depth that why a rectangle must always be a parallelogram, but right now let's just take it that's a parallelogram. But we know in a parallelogram that the diagonals bisect one another, so that means this diagonal gets cut in half, so we know that 3C minus 26 is equal to C. So adding 26 to both sides, subtracting C from both sides, we get 2C is 26, or C is 13. Now I said just take it from me that this is equal to, let's bring this down. This is equal, or this is a parallelogram. Why is a rectangle parallelogram? Well, the definition of a rectangle is a four-sided figure with four equal angles, which means they must all be 90 degrees. So think about this. If I have two 90-degree things, I know these are perpendicular, so the left side and this is perpendicular. But at the same time, if we have another one that's perpendicular, that means we make a 180-degree turn. So necessarily, this top side and this bottom side must be parallel. It must be going in the same direction. Same logic applies that this left and right side must be parallel. So every rectangle must be a parallelogram, and so must have all those properties we just discussed. Okay, so another parallelogram. The problems are starting to get a little repetitive, so I hope that was useful. Good luck, and I hope you enjoyed.